Alright guys, so today we are here in our ChemBank. So under our tools part, right, in the ChemBank, we're gonna go to simulations and I'm gonna attempt to use the simulation to teach you what is going on for hybridization. Okay, without further ado, let's go. Okay, so here you have your atomic orbitals, your 2s and 3 of your 2p. Then you have your carbon atom. Okay, so if you notice on the right, you have your 4 valence electron. 2 is in the 2p orbitals. 2 of them is in the 2s. This is in the ground state. If you were to use them directly, right, you will find that, okay, the 2p orbitals used to form the bonds will form weaker, slightly weaker bonds due to a not so efficient orbital overlap. Okay, and then the 2s will form slightly stronger bonds. Now that doesn't make sense because we know that the 4 covalent bond that carbon forms should all have equal strength if they're formed with the same atoms. For example, CH4. All your 4 CH bonds should be the same strength. Okay, so hybridization will solve this problem. So we're gonna use hybridization. So first one is sp3. We're gonna mix all 4 of these orbitals to form your 4 hybrid orbitals. So hybridize it. Okay, it's basically just mixing them up. So you see here now you have a tetrahedral shape. Bond angle is 109.5. Okay, yeah. So now, if you look at the energy level, all 4 of the hybrid orbitals have the same energy level. Thus, when you overlap with the s orbitals from hydrogen, you will get the same bond strength. Okay, so this solves the dilemma of you having different bond strength when bonded to the same type of atom. Okay, now let's take a look. If we were to pull them apart, that's how the individual hybrid orbitals will look like. Then we combine them together and then we pull them apart and then we combine them. Okay, stop. I have to stop playing. All right, now let's go to sp2. Now sp2, right? The situation is now that carbon needs to bond to 3 other atoms instead of 4. So we just need to form 3 hybrid orbital. Okay, we're gonna hybridize 3 of them. Voila. Okay, so now you have a trigonal planar hybrid orbital, 120 degrees apart. And you notice that one of the 2p orbital has not been hybridized. This unhybridized 2p orbital will later form your pi bond. Okay, so when does sp2 happen? It happens when carbon needs to form to 3 other atoms. Okay, so sp3 is when it needs to form to 4 other atoms. Okay, now let's break it up. Once again, you can see the 3 hybrid orbital, slightly lopsided. Okay, combine them, open it up, combine them. Yeah, okay. So that is for your sp2. Now let's look at sp. sp, we just need to form 2 covalent bond with 2 other atoms. So carbon, we hybridize 2 orbital, one of the 2s and one of the 2p. Let's go hybridize. Okay, so now we have a linear hybrid orbitals. When we break them apart, this is how they look like. Put them together, take them apart, put them together. Yep. Okay. All right. Now let's look at how we're gonna apply this hybrid orbital in a molecule, in an actual molecule. Let's take ethene. Okay, so you have your ethene. The white spheres, right, are basically your hydrogen s orbital, so they are slightly smaller. So you see the carbon right in the middle there is orange, slightly small. Okay, so we're gonna push them together so that the hybrid orbital can overlap and the p orbital also can overlap. Okay, so let's do this. Merge them together and the p orbital also overlaps. Okay, so you see the purple color, this is your p orbital. your pi orbital, sorry, not p orbital. Pi orbital right here. Then this here is your sigma bond. This is your pi bond, sorry. This is your sigma bond. Pi bond, sigma bond. Right? Let's try that again. Combine them together, form your sigma and pi bond. Okay, so you can see that your pi bond is actually like two loops overlapping at the top and at the bottom. Right? So this is how you will actually show and display how the orbitals overlap when the question asks you for it. Okay, let's look at another example. This is a ethyne. Right? Let's do the overlap. Sigma bond form, the two pi bond forms. Okay, so you can see the pi bond are actually right angles to each other. And if I were to strip out the sigma bond, this is how just the pi bond will look like. Then this is how the sigma bond in the middle, how it looks like. Okay, so once again, put them together, sigma bond form in the middle, pi bond form perpendicular to each other. Right? Okay, guys, I'm gonna go back to our Chem tools, go to our ChemBank, and click right in. So now that we're logged in, right, we're going to go to some structured questions. And then we're gonna filter for 10-year series and concept. We want to look at like sigma and pi bond, sigma bond, pi bond. Okay, orbital overlap, hybridization. Okay, so we're gonna look at some questions. Then we're gonna show questions. Gonna print. Okay, so this is a function in our ChemBank where we can print out the worksheets. Okay, so we have both the question and the answer keys. Okay, so we can print a PDF copy, print it to the desktop, call it hybridization worksheet. Alright guys, so this is the worksheet that was printed out. Okay, let's look at the tutor's copy so that we have the answers ready. Tutor's copy. Okay, so maybe let's look at a simple question from 2018. So here you have phosgene, chlorine double bonded to O, two single bond to two separate chlorine atoms. Okay, so molecule of phosgene contain both sigma and pi bond. Draw labeled diagram to show how orbitals overlap. Okay, so this is literally what I had shown you just now. Okay, so in this case, instead of C double bond to C, it is double bond to O. The concept is the same though. So you have a sp2 of carbon overlapping with the sp2 of oxygen, and then you have the p orbitals of C and O forming the pi bond. Okay, so earlier on, I think we had looked at the ethene, right? So if you look at it, this is your sigma, and this purple is your pi bond. All right, so pretty much the same thing. You just need to actually draw it out and label it properly. Okay, so this will earn you like 2 marks. Okay, 2 marks. Very simple question. Then let's look at the next one. Okay, so this question is from 2021, paper 3. So we are talking about ethyne, C2H2. So it has a C triple bond C. Describe and explain in terms of orbital overlap, shape, and bonding in the ethyne. So you can actually draw out the hybrid orbital like what we saw earlier. So ethyne, right, forming the sigma bond and the 2 pi bonds. Okay, so you just draw it out and label it. Okay, the thing that's different about this question is that you actually need to describe. Okay, so each carbon is sp hybridized to sp hybrid orbital 180 degrees, and then two unhybridized 2p orbital perpendicular to each other. Okay, so the sp orbital will form a head-on overlap to form your sigma bond, and the 2p unhybridized orbital will form the pi bond. Okay, so you just write all this down. This will earn you a cool 3 marks. Okay, cool 3 marks. Okay, so for these and more similar questions, right, it's kind of quite repetitive. 10-year series is always the same type of question. Yep. So if you want to get access to all these questions, you can join us for free in the Telegram chat. You can get all this worksheet. And for access to the ChemBank, where you can get all this simulation, this particular one is free, so you can join immediately. Just go to the link in the description or in the caption, and then just click join and set your own password. All right. So the rest of the simulation, there are some that are free, some are under the recording package. So do consider joining us if you want access to all of the simulations to help you visualize chemistry. Right? I look forward to seeing you inside. Till next time, bye guys.